Good evening, one and all. Myself, Yashvi Sheth, and today it's the 11th session for the course Basic Principles and Calculations in Chemical Engineering, taught by Professor Subrato Majumdar from IIT Guwahati. So let's start with the session. For that, let me share the screen. Okay, so let's start with the session. So far we had discussed about what is material balance, what laws can be applied, like what laws are usually applied in chemical engineering. So we have studied so far some of those laws like Raoult's law, Dalton's law, ideal gas law. Then we had derived the equations for material balance and energy balance, and also like it was divided for two cases, one without reaction, with reaction, and also one in steady state and for unsteady state as well. So apart from that, we also had discussed in the previous session about how do we solve numerically the equations that usually appear. Like most commonly there will be, like you will encounter differential equations, you need to solve the integrations, you need to have the solution for such complicated equations. So, because it is not necessary that always the equation will be linear, or even if it is linear, then there will be some n number of equations. So, solving such n number of equations or n number of linear or non-linear equations or integrations, it is difficult. So, we had discussed about such equations, and let me give you the brief, like what was it? So it was for linear equation, you can use Gaussian elimination. So it can be applied for n number of equations, like it can, even if it is in lakhs or thousands, then we have softwares which will be able to use this method, and it will be able to solve. You just need to develop a code for this solution, and you need to understand the method. So after that, you can apply it for two equations, or it can range in thousands or lakhs. So another is also, like this is just one example. There can be another approaches as well. Another is non-linear, because linear is just one type. Majority occurs to be non-linear equations. So we studied about majorly Newton-Raphson method, or Newton's methods, you can say. So this is the most common method used like widely for solution of non-linear equations. So for both these approaches, the equations can range from 2 in number to thousands or lakhs even. You just need to develop a code and fit, like you can use MATLAB or some free softwares by which you can like just develop a code, even Python. So you develop a code and you just put up the values, because in industries, like the material balance and energy balance developed are so complicated, and the number of equations, such equations that needs to be simultaneously solved, quite more. Okay, so you need to have such tools. These type of methods and tools will be useful to you for such cases. Another technique we studied was for solution of integrals. So it was divided into two. One was trapezoidal. Okay, so we studied about both of them, and we studied how if the integral is complicated in nature, to solve it algebraically, then we apply this type of method, which is numerical method, where you find for different values of x, you find out f of x, the values of f of x, you uh, tabulate them, and you use these information and put up in the formula for trapezoidal rule or Simpson's one-third rule or Simpson's 3/8 rule, and you can get the solution for that integral. So this was all about we that we had studied. Now moving forward, um, sorry, yeah. So this, just a second. Yeah. So for like what we usually do in industries, we for any process solve the process, we need the information in input information parameters related to the size or anything like of for design. Then you need to know the physical quantities related to the process. Then you need to have certain correlations also, by which you will be able to relate one quantity with other quantity, or so. So all these informations you need to have, and you develop based on all the informations you have, you develop material and energy balances for any process. Okay, so like for the solution of these material and energy balance, so there will be like, as you know, this is the basics of maths. Like for solving any equation, let's say it has x, y, and z, like x, y, z variables. So for having a unique solution, you need to have three equations, three independent equations. Okay. So if you have dependent equations, then at the end, one of the equation will get eliminated, one or maybe two, and only one or two equations will remain. So for the solution, for exact solution or single unique solution, you need to have three unique equations. So similarly, if I want to solve the equations for any material or energy balances developed, it can be a group of or mixture of some material and energy balance, linear, non-linear equation. So, okay, so for n number of equations, you need to have, for the solution, you need to have, for example, n variables are there, then you need to have n equations, okay, for uh, exact, for getting the solution. Now, for that, you need to provide that data to the software so that it is able to solve. Otherwise, if this is not the case, then your code or any of the software will also not be able to give you the solution. So for getting a perfect solution, you need to have uh, the idea of number of independent equations. Okay, then you need to know what all are the variables associated. Okay, so it is not always necessary. Just a second. So it is not always necessary that this number of equation and all the number of variables, there will be also the reactions occurring. So all this will result, the number of equations and number of variables will be equal. Okay, so you need to know whether you will be able to get the solution for that particular case or not. So for that, there is one terminology known as degrees of freedom or number of degrees of freedom. So it can be denoted by NDF or degrees of freedom DOF. So, for example, if your process is taking place and you know, like you can develop the equations and you know, like there will be, if the variables are more, then you need to give certain information related to the process externally. Like, for example, if this is the process, any process occurring, if this is feed XA, XB, then there will be product P, IA, YB, and there will be byproduct B, let's say ZA, ZB. Now, if you know, like, if you don't know anything, you will not be able to solve, okay? So, you need to have certain basis for solution. So, after that, once you develop that certain basis or once you have certain data, then after that, you will be able to solve the process and you will be able to calculate the unknowns. So degrees of freedom is one such quantity which you find out and you know whether the system is solvable or not. And based on the value of that degrees of freedom, you will be able to know like what all data or how much amount of data you need to provide to your system so that it can be solved easily, or so that any programmable software, it is able to solve that equations. Otherwise, it will not be able to solve. So the formula for the degrees of freedom is nothing but it is number of unknowns. Okay, it is number of unknown variables. You can say number of unknown variables. Sorry, plus the number of independent reactions, because reactions add on new variables or new products and you consume the reactant. So reaction is added over here. Now minus what you do, because now like for in simply in maths, how can you say if my number of equations and number of variables are same, which is 3 minus 3, for example, is equals to 0, then 3 is the equation, 3 is the unknown. So you subtract, okay. So variables minus you subtract the number of equations because that much correlations you have. So by correlating that much variables, you will be able to get certain amount of data from those equations. So you subtract those and some additional auxiliary relations that will be useful. So from that also you will be able to calculate certain variables or data. So also like that you can subtract. So whatever the value comes, okay, so say for example, the value from this equation comes out to be 0. So what does that mean? It is the case similar to number of variables minus number of like variables and equations are same. So you will be easily be able to solve the equation like system is completely defined. Okay, and so in that case you do not need to supply any further information. Based on what information is provided already, based on that information you will get one solution for all the variables that are unknown. Okay, next case, that would be NDF greater than 0. It can be 1, 2, 3, anything. So what does that mean? That system is, so let's say it is 3 minus 2. Okay, so this is variable, this is number of equation, so it comes out to be 1. So what does that mean? That the equations are interdependent, and you just have, for 3 variables to be solved, you just have 2 independent equations. Okay, so which means that since 2 independent equations are there, then say for example it is x plus y plus z equals to 1, x plus 2y plus 3z equals to 3, then you have 2x plus 4y plus 6z equals to 6. So since these two equations are interdependent, or they are multiple of each other, then one of the equation can be eliminated. So you just have 2 equations and 3 unknowns to be solved. So this is nothing but a same line. Okay, so for this particular case, there will be n number of possibilities. Say you choose any x, or in another words, to solve the pair of equations, you need to supply. For example, if I give you for x for x equals to 1, you just solve these two equations. Then obviously, yes, these two equations will be solvable, because for now the x value is known to you, and there just remains two variables, which is y and z. Since you know x, so what you are doing by like this one means you need to supply, if you supply that one additional parameter, then this system of equations will be solvable. So if you have NDF equals to 2, so it means that if you provide two variables or values for two variables externally or manually, then the system will get completely defined and you will be able to solve it um, uh, or otherwise there can be n number of possibilities. So for example, NDF is 2, so or NDF is let's say 1. Okay, NDF is 1. So say for example, if you need to supply the mole fraction. Okay, so if you choose mole fraction equals to 0, then you will have some answer. Then if you have mole fraction equals to 0.1, then you will get some another solution. So in those terms, what you will be getting is, you will have many such solutions for different values of that particular variable that you are supplying. So you can say that for NDF equals to greater than 0, you usually have infinite solutions. Otherwise, there can be NDF less than 0, which means the system is overdefined. Okay, so there will be, in such case, there will be one more equation which will not fit or which will not be relatable to any of the other 3 or any of the other equations. So in that case, you will not be able to solve equations. So okay, so these two um, are favorable for solution. This is not favorable for solution. And so based on the value of degrees of freedom, you will be able to know what data you need to provide, or whether the equations can be solved or not. So I hope this is clear till now. Now moving forward, the next step, like once you give all the data, or once you have all the equations and once you have all the data, what you need to do is to solve the equations. So as you know that in industries there will be thousands or lakhs of equations that you need to solve with thousands of parameters, or there will be like you have studied that usually you use Newton's method for solution of non-linear equation. Okay, so if you want to apply Newton's method, then you know that it is iterative method. Okay, so you need to supply some initial guess, and based on that, it will come up. It will try to come up to a particular solution. Then you need to analyze whether this solution is acceptable or not. So it is always not possible to for you to solve uh, uh, thousands of equation, and that too in an iterative method. So what do you need? You need to have certain programs or certain methods by which you will be able to sorry, solve the equation. So one such method for solution is direct method, where you apply Gaussian elimination. So what is Gaussian elimination? Gaussian elimination is nothing but for n equations, step by step, you eliminate one variable at a time, such that at the end you will be able to get a solution, one solution for the n number of equations. So Gaussian elimination you can apply when you have n equation for n unknowns. Okay. So this is nothing but direct method. So next is iterative method. As I mentioned, Newton's method is iterative in method. Iterative method. So you start with an initial guess and you continue till the answer is within the acceptable limits, like which means that x minus xi plus 1 minus xi. Okay, so value of this is less than the error, or the error tends to 0, or it is, you can say, if not tends to 0, then it should be acceptable based on what process you are dealing with. So it depends on process to process also, like if it is acceptable or not. Now next is spreadsheet program. So spreadsheet program is like, for example, there will be inbuilt codes developed. Say for example, Excel. Okay. So inbuilt programs will be there. You do not need to do any further programming. Okay, and based on that inbuilt program, so since it has inbuilt program, it is easy to use, and various user manuals are also available, like how you need to progress. So you just need to supply the equations in either matrix form or so, based on what software or what tool you are using, and you just need to choose proper uh, um, method or options that are available in that program, and it will give you the correct answer. Now, the one problem that you usually encounter with such spreadsheet solution is that for complicated or for normal, like easy to solve equations which are very simple in nature, like if it is more in number, then easily you will be able to use that spreadsheet programs to solve or to get the solution. However, if you have the equations which are very complicated in nature, then like which is the usual, like which is usually the case if you look into the chemical processes, then for such cases, then you will not be able to use such spreadsheet for the solution. So in that case, so you use various flow sheeting programs or flow sheet tools. So for one of the example is Aspen, Aspen Plus or even Aspen Isis is there. So what you do here in this case, these are just the example. There can be COMSOL, ChemCAD, etc. So what you do, you develop the chemical flow sheet in each of these tools. So first step is develop the flow sheet. Then you second step is you supply externally. So based on so there will be some inbuilt database also, and also based on, say for example, you need to solve a distillation column. So for the solution of distillation column, what all data you need, then you it is already there in the that tool, or say for example in Aspen you are using, then if you choose distillation column, then it, already it will be there, like what all data you will need to give to this program. So once you give the data, then it might be able to convert. So you supply the data externally. Then what you do, uh, then based on the certain any like as I said, there will be some database. So based on that database, there will be already certain equations written in that. It can be material balance or energy balance. So it automatically provides you or develops the equation, and not only it solves material and energy balance equation and it gives you the final solution, but it also gives you the cost estimation or various parameters how it affects. So you will be able to develop various, like you get the result, you can develop profiles also, like how any, like if you want to check for distillation column, like how number of trays, or say for example, or how reflux ratio affects the value of product in distillate. Okay, so if you want to plot number of tray the quality in distillate of product versus reflux ratio or number of trays, then it is very easy to get through this programs or programmable tools. So this makes your task easy. Now there will be some certain inbuilt method for a solution of the equation. Okay, so one such method is equation oriented method and another is modular method. So in equation oriented method, what you do, you develop all the equations and you solve it. Either it can be solved simultaneously or it can be solved sequentially. So any of the thing can be done. Or another is modular method, like this can be more common, where entire flow sheet is divided into various number of subsystems or subsections, and for each subsection you write the equations and you solve it. Now those equations will be carried forward for the next uh, module or next subsystem, and you again use that for example, I will draw, this is 1, this is 2. Now that 2 is going to 3, 3 is going to 4, like so likewise. So what you do, you separate first this system, you solve it such that for 1 you get 2. Okay, next is now once you get this information for stream number 2, you use that information of stream 2 to solve this process, and you get information for stream 3. Now, so that is sequentially you solve each module, and you use that information of the previous module to solve further. Now, just a minute. So, there are so usually what happens is, you usually in industry observe recycling of process. Say for example, this is 1, 2, 3. Or it can be recycled here also. Like for simplicity, let's keep only less number of processes. Okay. So this is the recycle, this is the product, this is feed. Okay. So if you want to solve such type of flow sheet, which is the usual case, or because you will frequently encounter such cases in industry, like this is just one recycle, there will be n number of recycles in the industry. So solution, because you don't like, since the input to the stream is dependent on this R, and this R is dependent on what product you are getting, or like this P stream. Okay, so all this is interlinked. Okay, so you will only be able to solve the equation simultaneously, or what you can do, another approach is tiering. So you write the equation for each system separately. Say for example, you take unit 1 and you write the equations for unit 1 separately, you write the equation for unit 2 separately, or you do tier the stream, or you can like what, then how will it appear? This is feed, this is recycle R, this is 1, 2, this is again R, this is P, this is product. So now this can be solved. Okay, so like you start with a guess for any recycle stream or so, and you start with that guess, and you progress for the process. You stop once, like this is obviously an iterative method, so you will stop when the answers match, and the error is negligible. So this approach is nothing but tiering of cyclic process, or tiering of streams. So why do you do this? So that you will be able to solve the blocks. So now you will be able to you use modular approach, modular method for the solution, and you will be able to treat each block separately. So you try to match this R values, because this is like the same, so you need to match the R values. Okay, so far this is all about the theory for this session. Now let's move to the assignment part. The assignment is very simple. So the first question is, what does the number of degrees of freedom less than 0 signify? So in this beginning of the lecture only, I had discussed few cases, like if you have NDF equal to 0, then you have unique solution. For NDF greater than 0, you have infinite solution, or for NDF less than 0, you have no solution. Okay, so this is completely defined. This is underdefined. This is overdefined. So for this case, NDF, since it is given you to you as less than 0, then the answer should be, it should have no solution. Okay. Next question is, when does a system have an infinite number of solutions? So here we had already written, when does a system have infinite number of solution? When the system is underdefined. So when you have NDF greater than 0. So the correct answer here in this case is NDF greater than 0. For that, you have infinite number of solutions. Next is, calculate the number of unknowns for the given flowchart. So this is the step that is usually done for calculation of degrees of freedom. Okay. So for this case, you just need to, you do not need to find out the number of unknowns. You just need to do calculate the number of unknowns. So for that, what you will do, let's say what all parameters you have. So you have, this is nothing but M represents the flow rate or the mass of that particular stream. So this is stream 1, 2, 3 and 4. So for all the streams you will have mass of like this is S represents sugar here, W represents water in that stream. Okay. So for you are taking M1 as the stream of strawberries, you are giving it to the process which is having M1. Now M1, so M1 is like parameters. Okay, so M1, and for that stream you have two um, cases, like the mole fraction of, what is the mole fraction of sugar and what is the mole fraction of water in that. So both like XM1S. So all these you already know. Okay, so that is not unknown to you, that is known to you. So you do not need to consider these values, like the mole fraction of sugar and water, you know, but you do not know what mass you are feeding to the process. So that is an unknown to you. Okay, so this is the first unknown. Second is the moles of sugar that you are feeding to the stream. Now it is just the moles of sugar. So it means that, like, moles of sugar you obviously don't know, so M2 is also unknown. But what does this signify? There is some hidden line behind this. So it is just pure sugar crystals you are providing. So here you can say that water or moisture or XW in this is 0. So it is pure sugar. So the mole fraction, like in a way you can say that mole fraction of sugar in this is 1 and mole fraction of water in this is 0. So you know the composition of sugar here. Next is the product stream is one is like water is evaporated and another is jam. So now like M3 is water which is evaporated. Now you can say that sugar is a solute, so it is never evaporated. So for stream M3, obviously the mass M3 is unknown to you, but the composition is known to you, obviously, because it is completely composed of water So M3 is pure water vapor and it does not have sugar. So mole fraction like sugar is 0 lb sugar per lb, like for this M3. Okay. However, it is entirely water. Next theme is M4. Obviously, like M4, the value of this is given, like you need to produce this much moles of jam. Okay. And also like what quality of jam should be there? It should have this much sugar and this much water. So it will maintain the consistency of that jam. Okay. So you for M4 stream, you already know the mass, you already know the composition also. So any of the thing is not unknown to you, like all of this you know. And otherwise there is no reaction also occurring. So based on that, you can say there are three unknowns in the particular process. So I hope you are like I am able to explain and you have got my point. Now moving forward to the next question. Here you need to find out the degrees of freedom for the particular distillation column that you are given. So what data you need for calculation of degrees of freedom? You need number of equation first, like second you need number of unknowns. If reaction is occurring, then number of reactions also you need to know. So here, since it is a distillation column, a unit operation, then you can say that there is no reaction. So third option eliminates. So you need to know what all are unknowns and what all are equations that can be obtained from this flow sheet. So here you can see that all this data you have the data for the distillate. So since you have the data for flow rate, like the feed and the distillate, you will be able to automatically calculate the bottom. Okay, so this is how you calculate F equals to D plus B. So B equals to F minus W. Since you know F and D, you will be able to know B, which is 100 moles per hour. Apart from that, what you can say, like, so you can say that there are three unknowns in this case, like one is B. So like, let's keep this aside that how can you solve. So let's say you have three unknowns in the form B. Then you have XAD. Now, if you know XAD, then you have XBD. Then you have XAB, then you have XBB. So let's say you have 5 unknowns. Okay. Next is you need to find out the number of equations. Independent equations it should be there. Okay, so equations would be, so one you write overall mass balance equation, which is nothing but F equals to D plus B. So from which I said that you will be able to calculate B. So if you do not consider this as unknown, then you do not need to consider this equation. Okay, so for now we are considering. Second equation will be, since it is a binary system, then there will be equation like one component wise balance. Okay, because another is like once you know one of them, another is automatically developed. Okay. Next is this two equations, because so two more equations you have. So number of equations are 4. So you can say that degrees of freedom equals to number of unknowns minus number of equation, which is equals to 5 minus 4, which is 1. So 1 degree of freedom you have. Next is a mixture of ethylene and nitrogen is fed to a reactor in which some of the ethylene is dimerized to butene. How many independent molecular species are involved in the process? So you just need to check what all molecular species are involved in this. So you can say that for like here C2H4 or ethylene is fed along with nitrogen. It can be as inert or purging agent or whatsoever its use is there. But you are feeding C2H4 and N2 to get um, C2H4, some moles of unreactant C2H4, then C4H8, which is the product, and N2. Okay, so here the species that are involved, it is nothing but like it is asked in the form of molecular species. So you can say that C2H4, C4H8, and N2, they all are involved. Next question is um, propane can be dehydrogenated to form propylene in a catalytic reactor. This is the reaction occurring, and a process is designed for 95% of overall conversion of propane. So we are given with 95% of overall conversion. Next is, so this is one info you are given with. The reaction products are separated in two streams. So this is a separator. So these are the reaction products, and these are separated in two streams. One is product stream and another is recycle stream. So the first stream, which is the product stream, contains H2, C3H6 and propane. And you know how much amount of propane is leaving this stream from this stream, which is 55.5% of what leaves the reactor. So if this is N3, then it is 55.5% of N3. Then second stream is contains the balance of unreacted propene. Okay, so this also you know, and propylene, which is equal to the amount of 5% to that which is in first stream, is recycled. Calculate the overall degree of freedom. So let's calculate the number of unknowns. So here you have is N1, N2, N3, N4, N5. Now since N6 is related to N3 with this equation, you can neglect it here only because that variable and one equation you will get, so you can neglect. Okay. Another is 5, then you have 6, 7, 8. Okay, this you know. So 8 unknowns are there. You have number of reaction is 1. Okay, then how many equations you can develop? Okay, so for this case you will be able to have one equation, like one overall equation. This F like feed equals to rota. Balance. So this is equation number 1. Then another equation you will be able to write at this junction. Okay. So here you will have recycle plus feed equals to the mixture. Let's say this is the mixture. So this is the balance at point A. Now there will be reaction. Now again there will be a separator and you will write equation at the separation point, which is nothing but, let's say this is P equals to product plus recycle. Okay. Now this is all about the overall balance, or like overall system balance, or and module wise or the process wise overall balance. Now another you will be able to write is component. Here you can say that this is 3-component system. So overall you will have 2-component balances, or it will be just one because 2 of them are products. So you will have 1-component balance based on like conversion that you are given with. Okay. Next is you will be able to write, since here there are just 2 components, so here you will be able to write 1-component balance. So one more component balance here, balance at A. Then you have here 3 components, so 2-component balance at separator. So far you have got 1, 2, 3, 4, 5, 6, 7 equations you have. Now further if you see, you can say that the number of moles of H2 that are formed, same number of moles are leaving with the product. So one more equation is nothing but N5 equals to N8. Okay. Next, also you can say that here it is mentioned that propane here you are given, and also there is one more relation that N6 plus N, this is 9. Okay, so this is N9 equals to N3. Okay, so this is also given because it is said that which contains the unreacted propane. So it will be the rest. Okay, so that also component balance can be written. So based on this, you can say that you have 9 equations. Okay, so if you want to find out number of degrees of freedom, so it will be nothing but unknowns plus reactions minus equations. So unknowns are 8 plus reaction occurring is 1 independent reaction minus number of equations 9. So which means you have 0 degree of freedom, which is system is completely defined. So answer here is 0 degrees of freedom you have. Next question is, hydrocarbon gas is burned with air. The dry basis product gas composition is this much, and there is no atomic oxygen in the fuel. So what is the number of independent equation that you can have? So number of independent obviously the overall material balance. Okay, so this is 1. Then you have, let's say in this 1, 2, 3, 4 components. Here what mole percent you are given is in the form of dry basis. So in W is obviously you will not consider in this. So you will have 3 component balance equation. Like you can say that XCO plus XCO2 plus XO2 plus Xn2 equals to 1, because it is in dry basis. H2O is like mole fraction of H2O is not considered in this. So you can say that three, if you know three of them, then you will be able to get another. So you can have three independent component wise balance. So you can say that independently you have four equations. Going forward with the next question, it is saying that what is the condition to be fulfilled for the system to have unique solution? So this condition we had already written. So let's write it again. For NDF equals to 0, you have unique solution because the system is completely defined. For NDF greater than 0, you have underdefined. For NDF less than 0, you have overdefined. So here it is asked about unique solution. So system is NDF equals to 0. Okay. Next question is, which of the following is an example of independent equation? So gas law, which is nothing but PV equals to nRT. Sorry. Energy balance is like, obviously you will have independent equations like accumulation equals to input plus output, like sorry, minus output plus generation minus consumption. So you will have one equation from this also. Then you have stoichiometric relation for system with chemical reactions. Okay, so say for example it is C plus O2 gives CO2. Then what you can write for 1 mole of C carbon, or let's say this equation. CO plus half O2 gives you CO2. Okay. So for 1 mole of CO present and half mole of O2 consumed, you will get 1 mole of CO2 formed. Okay. So like if you know like what amount X is consumed, uh, either of CO or of O2, because since it is a stoichiometric relation, like for X moles of CO consumed, you will have X by 2 moles of O2 consumed and X moles of CO2 produced. So you will get relations like if you know what is consumed or formed, you will be calculate other uh, values of products or reactants. So obviously you will have the equations from this also. So yeah, all this are independent set of independent equations. So all of the above is the correct answer for this question. I hope it is clear so far. Now moving forward with the next question, what is the first step to perform the degree of freedom analysis? So what all you do for calculation of degrees of freedom? So first you define or understand the process, and it is simpler if you draw a flow sheet for the process. So if you draw a flow sheet, then it will be simpler. So to understand the process, then you know what all um, find out the variables. Then you write equations associated with the processes. Then you find out reactions. Then you uh, put in formula to calculate NDF. So if you look into the option, first one is you draw the flow sheet or flow chart. So this is the first option. So obviously this is the correct. So uh, counting the unknown variables, then subtract the independent relations from the unknown variables, and write down the independent equations are all the subsequent steps which is listed, like how you proceed. So this is how you proceed: first, second, third, fourth, fifth. So this is the process in which like this is how you proceed. So correct answer for this question is draw the flow chart. Next is, what is the disadvantage for using a spreadsheet program for solving the material balance problems? So here you can, like, spreadsheet is very easy to use. So ease of execution is obviously the correct like advantage. Then it has reasonable speed. So obviously this is also advantageous. It is handling intricate material balance equation, which means you do not you are able to handle difficult material balance equation. So obviously this is not correct, because this is one of the disadvantage, because you do not solve complicated equations. However, its cost of execution is low. So the answer here, like what is the disadvantage, is handling intricate material balance equation. Next question given to you is, which of the following is used for executing flow sheeting, or tool by which you execute a flow sheet? So you are given a table in the lectures taught by professor, where you were given the list of all the programs or tools by which you execute or solve a flow sheet. So Aspen, then you have Concept, then you have DWSim also, then you have ChemCAD, then you have Aspen. It can be of two types: Aspen HYSYS, it can be Aspen Plus. So here in the question you are mentioned just Concept and Aspen. So both of them are used for execution. So you can say that both A and B is the correct answer in the question. However, there are another softwares or tools by which you execute the flow sheet, which I have listed few of them here. And also you can look into the lecture to get to know what more tools you can use. Next question is about tiering. So what does tiering mean? So tiering I had explained in the like starting of the lecture, like when I was giving you the brief of the lectures. So tiering, when do you use? When you have recycling in the process. So what you do, you tier the stream. Like tiering means you break the stream into two. So you can say that this is looks. So you are breaking the stream. So you are partitioning the stream. So when do you use? When you have, like, such systems are called, or processes are called as cyclic process, because all the terms, like there is a loop, like you can see that, like it is a closed loop, like there is no opening. So you open the closed loop by tiering one of the streams. It is not always necessary to tier this recycle stream. You can always tier this stream so that it can give you this, like this will be dotted. So it will give you this flow sheet. Okay, so again, which type of tiering you will use, that will depend on what, like, you, for each of the tiering case you will write the process like the equations related to each process, and the ones in which there are less number of equations, or the one in which there are easy to solve equations. So those, because you are dividing the streams, so equations will be obviously different. So the ones which has lesser number of independent equations, or lesser number of equations which are difficult to solve, that you select. So tiering is nothing but, for this question, tiering is nothing but resolving a cyclic partitioned unit into a acyclic one, so that you will be able to solve. Another option is resolving an acyclic partitioned unit. So acyclic is nothing but you have an open loop. So you do not need to break any of the stream or tier any of the stream for a cyclic process. So option B is correct for this question. You resolve a cyclic partition unit to an acyclic next question is choose the correct statement from the following. So let's read first. There is no need to provide any input information to the code to solve the material and energy balance problems. So it means that you just have equations with unknowns. You don't know anything else, or you just uh, don't know the equations and you just have some variables with it. Because you don't have input information, so you will not be able to write the equations, and based on that you will not be able to solve. So this is obviously a incorrect statement, because without having both the information, or without giving any information about the input, you will not be able to solve any equation. So this is incorrect. Next question is, next option is set of linear or non-linear equations can be solved simultaneously using an appropriate computer code. So this is a correct option. So answer would be this only, but let's look into another options as well. All flow sheeting codes do not require an information flow sheet. So this is obviously an incorrect option, because without providing the flow sheet or information about the flow sheet, detailed information what is required by the tool, you will not be able to solve any code, because input you are not giving to that system. So this is an incorrect statement, because without knowing the flow sheet, how will you connect, or how will you solve? So this is incorrect. Then the option is the interconnections between unit module may not represent information flow as well as material and energy flow. Interconnections obviously by default mean like you know how it flows. So interconnections tell you about how it is flowing. So this is also incorrect option. Okay, so the correct answer in this question is option B. Set of linear and non-linear equation can be solved simultaneously using an appropriate computer code. Next question is, you need to find out the degrees of freedom for the process in which the drying of solid is occurring. So let's write first number of unknowns. We are given feed, and you are given what is the weight of water in it. So obviously you will know what is the weight of dry leather in it. Now it goes so this stream is completely defined. Okay, so stream 1 is completely defined. Now it goes to the dryer. There is no reaction, because it is just the unit operation of drying. So it separates into two parts, which is water, which is evaporated, and then you have product P. Now product You know what is its composition, but you do not know at what flow rate it is coming out. So unknowns here you have, because since water is evaporated, it is like leather cannot be evaporated. So the composition is known here. So what you do not know, W and P in this system. Then you have, if you write number equations for this case, then what you do, you have first this overall material balance equation. So you write overall, which is nothing but F equals to W plus P. Now then you have one, you will get, like, since it is a binary system, which is just a second. So what does binary system mean? Binary system is nothing but you have two components. One is moisture and one is another is leather. So for binary system, you will be able to write one independent component balance. Okay. So based on that, you have two equations and you have two unknowns. So, and since there is no reaction, so number of degrees of freedom is number of unknowns minus number of equations. Okay, so number of unknowns is 2 minus 2 equations. So you have 0 degrees of freedom, which means system is completely defined and you will be able to get one unique solution for what is the amount of the water you are getting and what is the amount of product you are getting. Next question is if you need to say whether the statements are correct or not. So let's read out the statements. So first statement is, if the number of degrees of freedom NDF is equals to 0, then the system is completely defined and you get a unique solution. So this statement is, we have discussed many a times, and this is a correct statement. So first is correct, obviously. Then second is, if NDF is less than 0, the system is underdefined, which is wrong. It means system is over-defined and underdefined has NDF greater than 0. Okay, so for this case, it is incorrect. So you have statement 1 as correct and statement 2 as incorrect, which is option D. Let's talk about next question. So if the degrees of freedom is greater than 0, so such type of questions we have discussed many a times, which means that you have there are an infinite number of solutions. Next question is, choose the correct statement for modular codes relative to equation-based codes. The modules may require a fixed precedence order of solution. And another option is, convergence may be slower than in the equation solving code. So the correct statement is A in this case, because modules may require the, like, you need to have the path like in which you will be able to solve. However, the convergence in equation solving mode, because if you solve it simultaneously, then it would be slower. So option A is correct. Then the tool Aspen Plus is used for the solution of well-known and hybrid intensified unit operations, or it is indicator-based method, or it is model for economic evolution, or it is component property analysis. So the correct answer is well-known and hybrid intensified unit operation solving. So because it is a tool to solve a flow sheet. So any well-known or hybrid intensified process or operations you will be able to solve using unit Aspen Plus. Then predict the nature of the system. FBD are the molar flow rates of inlet and outlet streams. XI is the composition. You need to find out whether the system is completely defined, over-defined, or unique. It has unique solution. So basically, you need to find out what is the degrees of freedom. Okay. So let's first write out unknowns. So this is a completely defined stream because it is a binary distillation column and you are given with both the mole fraction and the flow rate. So it is completely defined stream. Then also the distillate is completely defined because you know both the mole fractions of both X, A and B in distillate, and also the flow rate is known. So this is also completely defined. However, the entire stream of bottom is not defined. So B, XAB and XBB are not known. So you have three unknowns here. Then how many equations, independent equations, you will be able to write? So you can say that one, you will have overall mass balance, which is nothing but F equals to D plus B. So once you solve, you will be able to get B. Then you have overall component mass balance, which is nothing but you can either write for A or B. And once you write A or B mass balance, then you will be able to get either XA or XBB. So this is equation number 2. So now you know 2. Third is once you know XA or XB in bottom, then XBB plus XAB equals to 1. So if you know any of them, you will be getting another one. So this is the third equation you know. So you have three unknowns and you have three equations, which means NDF equals to unknowns minus equations. It means 3 minus 3 is equals to 0. So NDF is 0 means it is a completely defined with unique solution. Okay, so let's look into the options. So it says that the system is completely defined. So it is correct. System is over-defined, which is not correct. And you have unique solution for NDF equals to 0. So both A and C are correct for this question. So answer for this question is D, both A and C. So that's it from my side today. I hope everything is clear to you. So I will stop here for today and thank you for joining. Thank you for listening. I will stop sharing my screen and I will end this meeting. Okay, so thank you.